Well, hello and welcome everybody to the Pages Early Career Network Regional Representatives North America Show and Tell series. Today we are joined by Dr. Clara Rodríguez, who analyzes tree rings from the Andes. Clara is a trained geologist and graduated from in environmental science from the University of Geneva in Switzerland. And currently she is a postdoctoral fellow at the Tree Ring Lab at La Montorte Earth Observatory at Columbia University. And her research interests are the external geodynamic processes in mountain areas and their interactions with climate variability and human communities as well. And she's mostly interested in the interplay between climatology, natural hazards, with a special focus on magnitude frequency relations between mass wasting processes in high elevation environments, for example, flash floods or debris flows or rockfall, etc., and also the derived risks that come with that. To deal with the frequent lack of systematic data in mountain areas, Clara combines tree rings, analysis, and environmental history to construct continuous spatial-temporal reconstructions of past geomorphic, environmental, and hydroclimatic changes. And during the last 6 years, she focused on rainfall-related flash floods and debris flows occurring in the Peruvian Andes and their relation with the El Niño Southern Oscillation cycles. And the part that she loves the most about her job are the field trips to the mountain areas. And since it is something that she also likes to do during her free time. And Clara is now giving us a short trip, a short introduction to the dendro tree ring approaches in general, and then also a short trip during the lab. Due to some internet conditions, we had to pre-record the talk, and so we will hope that it works everything nicely with the video. Please, during the talk, you are allowed to ask questions. You can put them in your chat box at the bottom, or you could also raise your hand so that we see who is having a question, and then you could unmute yourself and ask your question. And with that, Clara, I would like to give you the screen and the microphone. Thank you very much for joining us and enjoy it.
Well, thank you, Tobi. Hi, everyone. This is going to be a bit different talk, not so science, more like to show the behind the scenes of science, and in this case of dendrochronology. I know many of us, overall people who work with geochronology stuff, we do field works, we spend a lot of time getting samples from many places around the world. So I wanted to show you my last field trip. It was in Peru last summer with the objective to collect some samples from tropical trees, and well, I will show you in the presentation. So first I will, let me share. Okay, we had some technical issues now, so please let me know if everything is fine. Can you see my perfect? Can you see my full screen? So yeah, I mean, dendrochronology, probably many of you already know what is that. Is the science that study and date annual rings from trees, and is a complementary science for any other science like archaeology, climatology, ecology. So it's more a tool than a science. Even if it's a science, probably some dendrochronologists will kill me now. So in the past, I have used tree rings to reconstruct climate and geomorphological events related with extreme rainfalls. So here in this talk, I'm going to talk a bit more about the methods that we use for dendroclimatology, because all of the application has different kind of methodologies. So we will need several talks like that to explain you all the methods that we use. So why are tree rings important and why they are useful to reconstruct past environmental past environmental conditions? Well, first of all, trees are around the world. I mean, they are distributed all over the globe. So the records that they are recording climate of everywhere. So this is useful because then we can, studying tree rings, we can match reconstruction from one part of the globe or others. So this is useful because give us a global vision of past climate. Also, they are nice because they can live for 100, even in some cases, thousands of years. So they are witnesses of what is going on in the earth for so many years, and they are recording that annually. So it's a kind of library of past environmental conditions. Is a kind of information that as the layers in the lakes or in the ice cores give us a full vision of what was happening in the earth, even much before that the first instrumental data was present. So the mystery of the trees is that meanwhile they are growing, they add a new layer of wood every year. So to form this ring, the tree uses what they have in the environmental, the resources that they have around them. So these resources are water, minerals that they get from the soil, and CO2. And they use these resources to manufacture nutrients that they use to create these wood layers. So the environmental conditions that where they grow, they impact the availability of these resources, as also the metabolic process that the trees use to create their nutrients. So a signal of these conditions is annually recorded in every tree ring. And in different ways, we can study the tree ring size, the density of the wood, the isotopic content, different anatomical characteristics. So all these things that we can learn from the tree rings, we call it proxies. So why? Okay. So tree ring research is something that is widely done around the globe. However, if you see here, every white dot is a chronology that someone has developed and somewhere in the globe. And if you see, most of them fall in the areas that are coincident with temperate climates in the north and in the south hemisphere, and very few chronologies are developed in the tropical area, and there is a reason for that. So in general, the trees in temperate latitudes have annual spurs of growth, because in the spring and in the summer they found good conditions to grow, and then during the winter they fall in a dormancy period, which creates this distinctive pattern of light and dark bands that probably you have seen many times in the stumps in a forest, or even in the furniture of your house if you have pine furniture. So this is different in the tropical areas, where the conditions are much better in terms of temperature and water availability. So the tropical trees usually grow year round. So they don't have this alternating dark and light bands. So it's much more difficult to distinct this annual growing, which is the key factor for us to reconstruct the past of the environmental conditions. So for many years, the dendrochronology in the tropical regions has been hampered by this thing, but now we have found new opportunities on that. And these opportunities are related with the trees from the tropical mountain areas, as the regions where I am studying, and also the development of new techniques that can be useful to explore different tree ring proxies other than the tree ring, that is the one that is more affected by this tropical behavior of the tree. So now here in the tree ring lab with my team, we are trying to fill this gap in the tropical regions, and we are trying to generate new tropical tree ring chronologies where we can annually see in our case, the climate variability of the region, and absolutely date every tree ring. And we are doing that in my case, in the Peruvian Andes, but other people in my team is working also in Bolivia. So why this region is because the Andes is a mountain range that probably runs from north to south of South America. And the Andes are in a very strategic place from the climatological point of view because they have the influence of the South American monsoon system and also the influence of the ENSO. And they receive both signals from west and east. So it's a very good place to record this signal that is important for climate reconstructions in South America. And as you can see, this is a climogram of this is specifically from the region where I'm working on. So even if it's a tropical place, you still can see a dry season and a very wet season. So different seasons is the thing that mark the annual rings in our trees. So we need to take advantage of this fact and try to get chronologies from tropical mountain forest. So last summer I did a field work in Peru. So the region is the Vilcabamba mountain range that is near Cusco. Probably many of you know where Cusco is. So this is in the central Andes of Peru, and we had the opportunity to take samples from 5 different sites. So all the sites, all this region is ranging between 2,600 meters until 5,000 meters. So it's a very, very high region that is also in the boundary between the Andes and the rainforest, the Amazonian. This green part here in the north is already the lowlands of are not the lowlands, but is like the transition between the Andes and the Amazonian forest. So it's a really a strategic region because the trees here are like in the limit of their ecological distribution. So this means that they are more sensitive to the climate. So this part of the talk is just to show you how we manage to get the samples. So of course everything starts with tons of material that needs to be move around the country, from the airport of Lima to the mountains in the south of the country. So not fancy things here. We just need to look for cars that are able to transit these kind of roads. Of course, not all the roads are like that, but they are not good anyway. So it's take us like 2 or 3 days to reach the sampling sites. And once we arrive to the places, then we need to reach the forests that are not usually close to the towns. Actually, we are not looking for forests that can be anthropogenically affected. So we usually walk a lot until reach isolated forests, that they are super high and they are super far from everything, just to try to get sure that they will not have any anthropogenic affection that can include some noise in our data. So sometimes we can reach the forest and go and back at the same day, and sometimes we need to, because we need several hours to reach the places, then we don't have time to sampling and then come back. So many times we need to stay there for several days and just leave in a camping setting. So we need to transport the material, the scientific material, but also the material to live there. So in this field work, I had the opportunity to visit 3 kinds of mountain forests. I had prepared a video here just to show you a bit how the high altitude Andes looks like, but the video is not working in the presentation. So maybe if I have time, I can show you later. But basically in the video, what I'm showing is this kind of landscape. You can see here, this is more than 4,000 meters above sea level, and almost nothing grow here except some herbs and the polylepis. I mean, those trees are very special because are together with some Himalayan species are the trees that grow higher in the world. So they are really live in extreme conditions, so they are very useful to record climate and climate variability. This species is these species are distributed along all the Andes from Colombia, I think, to Bolivia and Argentina, and they has been using in the recent decades to reconstruct climate, giving very good results. Then in the same region, a bit farther, you can see that the landscape changed a lot, and here we have more humidity. These forests of Escalonia are in the same mountain range, but facing the slopes, the Amazonian slopes. So here you can see that humidity is much higher, the kind of vegetation changed a lot, but still we are so high. So here for first time we are sampling this kind of trees, the Scalonias, with our Peruvian team already proved that they seems to be useful for dendroclimatology, but we still need to explore a bit more. So we got some samples from these trees, and part of my postdoc will be to see if we can include this species as a potential dendrochronological species. And then the last kind of forest that we visited, it was almost a rainforest in the middle of the mountain. It was a kind of island over there. Actually it's a sanctuary because these trees, the podocarpus, there are only 3 spots in all the world, one in Ecuador, one in Peru, and the other in Bolivia. And they are quite endangered because people use it to use the wood for fires, to get combustible and make furniture, and also many of the forests were burned to create crops and lands for the cattle. So now there are few places, and this forest is special because the biodiversity here is so high, and many of the species are endemic of this forest, and you cannot find it anywhere. So it's important to know what is going on this forest with the climate change and with everything. So we wanted to take samples from this place too, even if the dendrochronological potential of these trees is still in strike. I did something during my PhD. The results were not very good, but we are still trying to get better samples. So as I told you, these forests, all of them, the Scalonias, the Polylepis, and the Podocarpus forests, even if they are very different among them, they are all of them part of a region. They host a a lot of biodiversity that is unique in this area. And also many people live here in the mountains. They crops, these are potato crops, which is a fundamental part of the economy of many families in the Andes. So it's important to know what is going on here from the climatic point of view, because all these ecosystems are really sensitive and we really don't know a lot about them because not many people has been working on that isolated areas. There are many research about ice cores that they found amazing results, and all what we know is mostly about from this research. But I think that with Dendro we still can add some value to the research in this region. So basically during this fieldwork we got samples with increment cores. We also get some tree sections, and we installed 2 data loggers to record air temperature and humidity, because of course in this region we don't have many weather stations to measure rainfall or temperature, whatever. So all the data that we can get from here is very valuable, because there is no other data sources for climate data. So the plan is to leave these data loggers for 3 years. They are recording data every hour, and then come back after 3 years and see how the daily variability is and how the variability of rainfall and temperature between seasons is, because we only have data from the bottom of the valleys, and probably in this kind of complex terrain, the conditions will change a lot with altitude. So this is something that we want to see. Of course, I'm not working alone there. We are collaborating with a Peruvian team from the University of Huancayo. They are experts on this species in Polylepis, and also we were traveling with a biologist that provide us information about the specific species of Polylepis that we were visiting in every forest, because Polylepis is really diverse and every species change a lot in their behavior. So it's really important to have someone with us that is able to identify all the anatomic features of the external one, the flowers, the leaves, the bark, and identify the species. And also it was nice because she was a specialist in birds and orchids. So it was very, very nice to travel with her and learn a bit more. So now I'm going to stop to share this screen, and I'm going to share a video about the work that we do back at the laboratory to prepare the samples. I need to say that this is one of the things that we do here, just the classical dendrochronology studies. But on top of that, and this will deserve another video, we are doing isotopes and quantitative wood anatomy. Other colleagues of the lab are more expert on that than me. So I will just focus now in the classical dendrochronological methods to prepare the samples. So
Carla, probably before we move on to the video, we could probably quickly address the questions in the chat. So
yes,
some questions. So for example, thank you very much so far for this very nice and cool presentation. So Camilo Fuentes Peña asked, are you sampling or have you sampled trees from a tree line, like in the northern tree lines, for example, tundra forest, which represents the movements and redistribution of forests due to global warming?
Well, yeah, I'm not doing this exactly. Also, Polylepis is complicated species on that sense, because how the redistribution of these forest works is sometimes related with the anthropogenic pressure. So some researchers say that the redistribution of this species has been forced for thousands of years of people living in the Andes and using these forests for combustible or they burn them for crops or whatever. So we are not really sure about to do this kind of research on that forest, because probably the place where they are now is the result of a big pressure of all the land use that has been done in this area. So we cannot extract a lot of conclusions about global warming and say, okay, these forests are growing higher because the global change. We cannot say that. So
yeah, thanks so much. And are there any more questions just addressing the fieldwork or the general idea or approaches of dendrochronology? So now could be a good time to also just drop or ask this question. You might also just raise your hand so that you could unmute yourself. Romina Llanos, did you have any question? Not, okay, good. And I had actually, yeah, there's just another question here. Are these trees affected by any forest fire? I mean, did you see any fire marks?
We saw that. Yeah, that's why we need to walk a lot to find the forest, because the land use on this region are very, very related with fire. People here put fire to clean the lands and create crops, or just to give more nutrients to the soil. So it's a problem for us. So what we try to do is just to try to avoid the areas where we think that people can be managing this forest. And it's impossible to know until you reach the forest to know that, because I'm amazed how I mean, all the Andes, even if you see them like really isolated and high, it's amazing to see how the people adapt to this environment. So they really reach any part of the Andes and that region. So yes, we have seen forests affected by fire, and we try to avoid these trees and we don't sample them as much as we can, because sometimes the scars of the fire are old and they are inside of the tree and you cannot see, but we try to figure out a bit how to avoid this noise.
I actually also had a question regarding the miraculous polylepis tree. It really survives really harsh conditions, but comes also with very thin stems probably. Mm-hmm. How many years can such a polylepis tree incorporate?
Because the same problem that I'm telling you, many forests are not so old, but in some parts of Bolivia and the north of Argentina, they found, maybe some people here can correct me, but I think that's 400 years old, or right? I don't know if some of my colleagues here want to give the exact data, but yeah. And now we are working with trees that has more than 200 years old. That this is not so common because, as I told you, people has been using this species for different things since many years ago. So it's difficult to find old forest.
Yeah. Wow, impressive. Cool. Do we have any further questions just to the fieldwork related or to the general approach? If not, we could probably otherwise head on to the lab part. Yeah. And now here we unfortunately we were forced to pre-record the talk because the internet wireless conditions were a little not stable enough to do it in a live stream. We hope that it works with Zoom. Sharing videos over Zoom is always a little tricky. And in case it would not work properly, please don't be desperate. We would also make the video available on YouTube, where you could watch it afterward latest. Cool. Okay. But we give it a very nice try now, please.
Hi guys. So we are now here out of the Tree Ring Lab. I'm going to show you how we take samples from trees. So we are going to walk a bit now to the backyard of the lab, and we are going to enjoy a bit of this nice weather we are having today. Since, as you can see, 2 days ago it was snowing and it was so cold to record this video. So come with me and I'm going to show you how do that. Okay guys, so here we are again. This is the basic tool for the dendrochronologists. This is an increment borer. Which one basically the objective is to get a wood core from the trees. So usually what we do where we are going to the field to do field work and get samples is get as many as tree cores as we can. But sometimes if we have the chances to find dead wood, dead trees or dead branches, we take advantage of that and we try to get wooden sections. In general, wooden sections are much more useful for us because we have we ensure that we can see the center of the tree, and that we can get all the sequence of tree rings in any of the direction of the tree. This is important in the tropics as well, because the variability of the tree around the center sometimes is so high that if we just get a core from the external part to the center, of course you cannot be sure where the center is. So it's like you only have one chance to get all the tree ring sequence, and sometimes this doesn't work very well. So always that we can, we try to get also this kind of samples. But of course this is a much more invasive method to get the samples. So when we are working with living trees, we usually don't do that because you need to cut an important part of the tree, sometimes even the full tree, so we don't do that usually. So now what we are going to do is go to that tree there and show you how we extract the sample. Behind the camera is my colleague Arturo. Maybe we'll show up at some point of the video.
Maybe.
But well, for the moment we are here, and the way this works is that we leave this part here. We only put this orange thing because this is the most easiest thing that you can lose in the middle of a forest. So, and this tool is super expensive, so in order to don't lose that, we usually put this orange strap. So what we need to do is to drill the tree. Sometimes it's harder, but another times conifers like this usually are softer than other trees, so that's why I choose this tree for the video to don't stay so long sampling. So the idea is go deep as you can. Of course, this increment borer is so small for the size of the tree. For a tree of this size, we use a much longer and harder to manage increments borer. But well, for the purposes of the video, to show you, this is fine. So once we reach what we think that is the center of the tree, we introduce this part that is called the extractor, and we turn back and that way we obtain a core from the tree. From the bark, which is the most external part, to the center of the tree, that should be somewhere here. Of course, we didn't get the center now because the increment core border it was so small, but like that. So now we are going to cut the video, and then I will show you what we do with these samples, and in the meanwhile I'm going to take out the increment border from the tree. That is going to take a bit of time, so I see you a bit later. Okay guys, so here we are in the table again. So this is the sample that we just extract from the tree, and what we usually do after extract the samples is to put them in a straw like that in order to storage and transport them until back to the laboratory. And once we arrive to the laboratory, we need to really fast put the samples in this kind of wooden supports that we use to dry them. The idea is that they need to dry straight and don't get twisted in the drying process. So we usually put we glue the samples to the wooden support, and always paying attention to the wooden fibers to be in a vertical way, in order to see at the microscope to see the fibers and the vessels and all the relevant structures of the wood. So once the sample is dry and well glued to the wooden support, we sand it. We sand it in order to better see the tree ring boundaries, as you can see here. And once we have the sample on that way, we can start to date every tree ring, starting from the bark to the center. Starting from the bark because we know that we know when we have sampled the tree, so we know that the last tree ring, the closest one to the bark, is the last one, is the one corresponding to the year when we are sampling. So this is our reference, and then we start to count rings back to the center and dating all of them. In the next video I will show you how we prepare these samples until reach this state, and I will show you how is actually the wooden workshop of the tree ring lab. Okay guys, so we are now inside the tree ring lab. This is the workshop where we usually prepare our samples. So we have different kinds of sanding machines, depending on the kind of sample that we have, if they are sections or they are cores. We sometimes use one or others. I'm not going to use them because with the noise it's going to be too much for the video, but basically, for example, with the belt sanding machine, it's super easy because we put our boot like that, and then we start to work on that until we get a soft surface. Sometimes we need to cut some pieces of wood to prepare another kind of samples for wood anatomy or other purposes. So we also have this saw machine that basically we use to cut the wood in smaller pieces. So usually we cannot finish all the sanding work only with this machine. So overall with the increment cores, so many times we need to finish the work by hand. So we are here in the sanding station where we finish the sanding of the samples. Today we have Santiago here doing his job because here we work many people. Maybe it's a good idea if he explains you better how is doing that.
Okay. First, we have all like the samples from the workshop, the workstation, and with sandpaper and with a flexible surface, we finish the work of the sanding in the samples. So later, when we go to the microscope, we can see the surface better and see every detail.
Okay, thank you, Santiago. I'm sorry to disturb you. So now we are going to move to the measurement station, where I'm going to show you how we measure the tree rings. And then on live, I will show you the software that we use to create the final chronology. Hi guys, so we are now in the tree ring lab. This is our Belmex station, which is composed of a moving table, and a stereo microscope, and measurement recorder that record all the tree ring widths that we manually record with with all these settings. So what we do is with the microscope, we one by one we are checking. I would like to show you in the microscope, but we try and it's impossible. So I have a cross here in the visor. So every time that the cross coincide with a tree ring boundary, we click with this little button, and then the measurement get recorded in this machine. So then we move forward with the table. I don't know if you can see it, but we have a wheel here. So this is a calibrated wheel, so we can move the table very little as we want to measure very little tree rings. So we move from one tree ring from the other, little by little, and every time that the cross falls in a tree ring boundary, we record this measurement. So as you can see, every time that I move the wheel, this measurement is changing. So all these tree ring width measurements are keeping in the memory of the computer, and then we download this data and we start to work with them. Another way that we have to measure the tree rings is by scanning the samples, and then we got a high definition. Imagine we usually use this kind of scanner, that is a high resolution scanner. So we put the sample here, we scan the image, and then I will show you now in live in the computer how we process these kind of images to do the measurement in another way. So, can you hear me, guys? Yes, okay. I saw many comments in the chat. Thank you, Jessie, because I saw them late. I knew that the Niles will be a topic, but there is nothing wrong to be still is and almost died in the Andes. So, well, yes, as Jessie said, the structure should be always somewhere where you can find it, because I think that almost all of us, we have lost the structure, and if you lost this part of the tool, you have lost everything. So it's something that we always take care, and I usually put also in the bark, not this time, but it's a good tip. So I'll polish the extractor. Yeah, I mean, basically, Jessie answered all the important questions, so thank you, Jessie. Now, if you want, I can share my screen again to show you after scan the samples. This is something that when I started with Dendrochronology, I never used this method, but I always used the measurement station with the table. But now with the pandemic, that all of us, we needed to work from home, we started to work more with the scanning of the images. So I'm so we use this software is called Co-Recorder. So it's really simple. I mean, basically you have the image, and you do the same. You do the same here that with the table. You start to count the rings from the bar, where supposedly you know where the last ring is, and then you start to count back to the center, and that way you create a sequence of different tree ring widths. So this variability in the tree ring width is what is giving us this environmental signal. So we do that with many samples. I mean, we need replicability. So when we core, we try to core as much as possible to get a good sample deep. And when we have this kind of samples with all the section, we try to get also different radius of the same sample, since the trees are not perfect machines. So as you can see, we can find variability depending of the site where you are sampling. That's the thing that I explained you before. So if you have the chance to get sections, it's much better. It's much easier to date the tree rings and then cross date the samples. But this is not usual, and we only do dead branches or even dead trees. So once we have done all this measurement, for one tree, what we used to do is try to cross date all the radius, and normally they fit quite well between radius, and sometimes no. This means that sometimes we can have some missing rings in some part of the tree, or maybe false rings in another part. So we need to adjust our dating. And then we compare the tree ring wide series between trees. So to do that, we use another software. We have several of them, but the one that I'm going to show you now is this, the Dendro. So in that software, you basically load all your recordings. All these plots are showing the variability of the tree ring width. So what we are looking for is to try as much as possible of series of this kind, and we always look for the good matching or cross dating among trees. So never is perfect. Overall in the tropics, it's so hard to get this kind of good fits. But well, I mean, it's part of the challenge and part of the science that we do, fight with this and try to figure out why some of the, I think I added here, for example, here. I think that I added some samples that doesn't match so well, like this one. So basically, when we have series that doesn't cross that, maybe they are moved. You can find situations like that they don't fit. So you need to see if your dating is correct in all of your trees, and sometimes you need to move the datings, and overall if the trees were died when you take the samples and you don't know exactly the date when they died, and you need to match these trees with other trees that are alive. So you need to, it's a kind of puzzle. I don't know if it's a good definition, but you really need to try to make it match and make that they correlate each other. And once you have a good number of these series from different trees, then you are in the position to create a chronology that usually, I mean, for temperate forests, many chronologies has the hundreds of trees. For us, we don't have so many. So in tropical dendrochronology, we tend to use less number of trees because they are harder to find. They are not so old like the trees in the temperate areas. So we need to play a bit with these challenges from the tropical regions. And well, people working here, they know. I was not sharing the screen. Sorry. Is it again? So this is the second software that we use. So when we get the series, the 3-ring white series from co-recorder or from the table in the correct format, we include that series here. So what we can try is make to match all the trees. So for example, this matching is not bad, it's quite good actually for tropical regions. And the idea is try to have as many series as we can that matching as well like these ones, and create chronologies with that. Like and I mean is well what I explained you before. So yeah. So with this software, we adjust these are already adjusted, but sometimes you can, when you upload the 3-ring width series from the raw data here, you can find things like that. So then you need to figure out if these trees were growing in the same place, why they are not matching. Maybe you did some wrong in the dating, so maybe you need to go again to the sample and move your dates and see if it's possible that you lost some tree ring in the process, but because sometimes they are so narrow that you cannot see, and this we call that missing rings. Or sometimes the tree has density variabilities in one year, so you can think that instead one tree ring you have two. So all these things we need to fix it at the end. And probably we invest most of our time, dendrochronologists, trying to cross-date trees. And in tropical regions is even more challenging. So yeah, basically is this.
Great, thanks so much, Clara, for these very nice insights. Now we have some more questions to the technique. For example, how can we differentiate between a true ring and a false ring?
This is difficult, and that's why we need samples from many trees. I mean, if you have 50 trees that are giving you a signal, and then you have another one that it seems like has an extra ring that is not matching with all the others, then you can start to suspect that probably you have a false ring somewhere. So you need to come back to the sample, and with the stereo microscope, look at the anatomical feature, look at I mean, behind all this dating, we have a lot of process of see the sample, see how they grow, see how the wood the structure is, and try to really differentiate the boundaries of the tree. So it's something that you learn, are skills that you are earning with the time, and you really need to look at many samples of one species to have a real taste of how this specific species is growing and what you can expect from one tree ring, and try to identify where things in the structure of the ring that maybe are false rings.
Nice. And then there was one last other question concerning color enhancement, respectively, whether the darkness or grayscale of values of tree rings have an importance, probably for identification or in perspective of, yeah, make visible the dark layers more, enhance them.
Sorry, Toby, I didn't understand.
And the question was like whether the grayscale values, whether they can be used or whether that's used or.
It can be I mean, in terms of color, we can use that to identify the boundaries of the trees. This is, for example, I have here a sample. I mean, this is a sample from a conifer. I don't know if you can see well, but in conifers it's so easy. I mean, one tree ring, one annual band is composed by a light bud that is called early bud and a darker one that is the late bud. So, and this is always like that, and so it's easier. But then in tropical areas we have another kind of bud where this rule doesn't work. So color is important, but that's why you need to really know your species and where are you sampling and where are you getting your samples from, because this rule is not always working like that. So in general terms, yes, but tropical trees, they are special guys for that.
Yeah, that makes sense. Wow, yeah, diversity of trees. And that's really cool that you have given us the opportunity to have the insights also into trees coming from 5,000 meters above sea level. And actually, one question that ponders me since the beginning is, you're just on the western slope of the Andean Cordillera, right?
No, we are actually, I mean, it's an intervalley. It's a bit complicated because the Andes is not like that.
Yeah,
I mean, you have the Pacific slope, Amazonian slope, and then you have the Altiplano in the top, where you still have so many valleys. So it's not as easy as to say we are in the Amazonian or in the Pacific slope. You have a lot of microclimates there. But these ones are maybe more in the Amazonian side, so more humid than others in the
and so you would
slope.
Probably expect to see more influence from the Southern American monsoon system rather than the ENSO.
Is
like
yeah, is what we think. I mean, what we think is that they are influenced by both ENSO
definitely.
Yeah, because the signal of the ENSO is so wide from north, well, I mean worldwide, but specifically in Peru, from north to south and from the coast to the mountains and from the coast to the Amazonian, the signal is so different. I mean, it's not Peru is known because when they have these Niño events, they have a lot of rainfalls in the north and many disasters, floods, everything, but it's the opposite in the Andes. So, and it's different between north, central, and south. So in this region, the ENSO signal is more or less clear and is drier than in the north. So here you cannot expect like extreme rainfalls because of Niño. But also we have the monsoon system. So we are trying to understand this interplay between the ENSO years and the annual monsoon system, because they have interact and they modulate each other. So, and it's not very clear how this works. So we can find in that region, we can find both signals. So we are trying to understand how they interact with each other.
Yeah, cool. Thanks. Are there any last questions before we have to let Clara go?
I have another about the skeleton plotting. I don't know if essential, but is is useful, and when you learn with a dendrochronologist and you are in the first steps of your career, you always learn to do how to do a skeleton plotting. Is for the people that maybe is not used to this term, what we do is that first, when we have already the sample prepared and sanded, we start to date we put dates on every tree ring, and then with I don't know the name of in English, but these papers that with millimeters, like calibrated paper can be the term, I don't know. We do like plots, graphic plots with the narrower rings. So that way, and we do that for all the trees and for all the samples that we have. So we create by hand a visual image of every tree ring with series with bars that are indicating the narrower rings. So when you put together all these plots, you can imagine like a timeline and with different lines, and these lines means if the tree ring is narrower or wider. When you compare these plots that you make by hand each other, you can see if the trees are sharing some common patterns of tree ring with variability. So yeah, I don't have any image now of skeleton plots. I don't usually do now like in that way, because in the end, what I'm doing now is directly I get the measurements and then I go to this Dendro program and I play directly with the plots. But it's something that is useful to have to see in a first moment if your trees are matching or not, and also if you can find a clear pattern of decreased growth or increased growth.
Cool. Thanks so much. I guess Maddie had also raised her hand.
Yes, please. Clara, thank you so much for your time. I hope you don't have to be anywhere. I just have one question that is completely different than maybe what we've been talking about, but I was looking at your ResearchGate and noticed that you have a couple of really nice scientific publications, and then also some publications in Spanish language. So I was curious to know like what role those play in your program, and like who's the audience and how do you stay involved, you know?
Yeah, which one, Maddie? I don't have I had tons of, I told you, and I didn't remember to.
Okay.
Let me see, because I did in my, wait.
So it looks like maybe there's something about a climate report.
Yeah, I mean, during my, maybe it's this climate report, during my PhD, I did, I started to work trying to understand the relation between flash floods in the Andes and the ENSO. Because as I told you, usually we think that when we have El Nino events, we got a ton of flash floods in Peru, and it seems that it's everywhere, and it's not. So what I did, it was to, using the Desinventar database, that is a disaster database, I gathered all the events in the last 30 years, and from everywhere in Peru, mostly from the Andes, but also from the coast and from the Amazonia, and see if the big peaks of hydrogeomorphological processes were matching just with El Nino, or also La Niña and the neutral conditions of ENSO could play a role. And in fact, we found that depending of the region of Peru, you could find more disasters during La Niña or during El Nino. So this was an important addition because, and this is more politics things, it seems that when we have a El Nino warning, everyone around the globe, the red lights start to sound, and then Peru start to invest a lot of money on on disaster risk reduction, management. They clean rivers. They invest a lot of money, and they were investing many times in all the countries. Seems like all Peru is affected by that. So this was another point of view. The Geophysical Institute of Peru was interested on this. Then I found another atmospheric patterns that could be related with this kind of phenomena. So it was a more complex thing, but they wanted to share with the not scientific community in Peru. So they invite me to publish these results more in an informative way, to reach policymakers or people from civil protection, or I don't know, other kind of stakeholders in Peru. So we translate this research paper in this informative document that was published by the Geophysical Institute of Peru. Yeah, basically is that. It's like a easier summary of what I did in Peru, in my patent.
Thanks, and that's, wow, really crucial work. Also, aside from doing the core science business, to communicate that in a policy decision-making way, that's, wow, really cool.
It's nice. I'm really interested on this part of the science, too, in the way to try to, now I'm working a lot on dendrochronology, but I did a lot also in disaster risk management and natural hazard, which I will say maybe is even the part that I like the most. And it's interesting to see how the science stopped at one point, but then it's like all there's institutions, people needs another kind of information, and I would like to work more in this, building this bridge between science and policies and people in general. Yeah,
cool. Okay, well, I guess with this very nice statement, we would like to thank you again, Clara, for this very nice insight. And also, if people are worried about the quality of the video, please check out the YouTube video. We will put in the raw video so that we don't have any issues with frames or low frame rate, so that everything goes very smoothly. To see this very, very nice introduction in how we do dendrochronology. Thanks again, Clara, and thank you everyone for taking your time and to join us here today. And please stay tuned with us. If you not already have signed up to the ECN pages listserv, please do that. And so then you also will be informed about the next show and tell event coming up for the North American region. Cool. With that, I would like to close. Thank you very much. Enjoy the rest of your day and see you around.